In this set of equations, we're asked to identify which ones are perpendicular. Notice we're not given a graph. So I'm going to show you how to identify perpendicular lines without having a graph. But if you want more details onto how to, what does it look like with perpendicular lines in a graph, make sure you check out the video included in this section of the worksheet. I go over more details as to, the reasoning behind why perpendicular slopes, like without a graph, if I'm looking at it here, is going to have this type of relationship. So, for example, let's say I have a slope, two numbers, a over b, right? A and b can be any number as long as b is not 0. Then perpendicular slopes to that would be b over a, and it would be negative. So these will be perpendicular, right? It's basically whatever the slope is, if you do the reciprocal of it, that will be your perpendicular slope, and they have to be opposite. So visually, this will be like a positive slope will be something like this, and if you have the negative reciprocal, it'll be something like this. And that'll form a 90-degree angle, which is what we're looking for, perpendicular lines. The other cases, if you could have, is a vertical line and a horizontal line. And those also form a 90-degree angle. A vertical line would have an equation something like x equal to some number. A horizontal line, like this one, will be an equation that would be y equal to some number. And that's what you would look for perpendicular lines if it's a vertical and horizontal line. So we're going to look for these two setups right here. Either are they negative reciprocals of each other, or do we have these types of equations in order for the lines to be perpendicular. So the format of the equation is going to help me out. And I can see here, I'm just going to split it up to identify the equations we were given. We have 4 different equations. And in this first set of this first equation, this is slope-intercept form, where you have y is already solved for. We have y by itself. And when you have y by itself, we know the slope is going to be the number multiplied with x, which is negative 5/3. This too is slope-intercept form, so I know that my slope is going to be this number here, negative 3/5. This one is also slope-intercept form, so I know my slope is going to be 3/5. And then the last one, notice that these all had x's. This has no x's. So if you don't see an x, then we know this is going to be y is equal to 0x. So we also know that the slope of this line is actually going to be 0. So the ones that do have slopes, we're looking for negative reciprocals of each other. So if I look here, this is a negative 5/3. The opposite of that would be 3/5. To be perpendicular, right? So this is my slope here. The negative reciprocal means the opposite sign. So this is negative, so opposite will be positive. Reciprocal of 5/3, switch places, will be 3/5. So this one, you're looking for these two slopes to be perpendicular. So I have one here, and I notice I already have one here. So I know these two equations are actually perpendicular. And I can see this one in the middle is not perpendicular to either of these, because this is not a negative reciprocal to 3/5, right? These are actually the same slopes, that one is positive, one's negative. And then these are reciprocals of each other, but they're not opposite signs. This is negative, and that's also negative. And then in this last equation, notice the slope is 0. Slope of 0 looks something like this. And to be perpendicular to this, to be perpendicular to a horizontal line, I mentioned earlier, you have to have a vertical line. And a vertical line will be the equation x equal to some number. And since we don't have any equations where it's x equal to some number, I know that this is not going to have another line that's perpendicular to it in this set of equations. So all we have is just these two equations that are perpendicular to each other.